So I'm Dan Mone, and I'm working on, appropriately enough, another library which is trying to make reusable D3 charts. So it's called Plottable, which is spelled kind of like plots in a table, which is what it is. So we've taken a similar approach to wanting to decouple from the data, decouple from display, and then also kind of break visualizations down into smaller parts like axes and plots, and have a layout engine to put them together. But so I'll just show you a few examples really quickly. This is like your standard bar chart. You have a function that takes an X scale, a Y scale, a color scale, kind of like plugs some data into it, merges it in with the axes, and renders it. And it's all controlled via CSS. So if I was like, maybe this title is too big, I want to make it 20 pixels, but the legend is too small, or the axis, you can just change that and reload it, and the layout updates automatically. Another example, and that's a problem. Let's see. So another example, all of these charts are kind of introspective. This one's showing the number of issues on the Plottable repository over time. The green ones are ones that have been closed, and the red are still open. And then this line is showing the total number of lines of code in the library. So you can see that the layout engine is kind of flexible. You can do arbitrary things like putting labels on either side. You can make more axes. We have this powerful timescale that just comes packaged as a component, and it can kind of like give you a lot of information as you zoom in and out. And then once again, the code is pretty simple. It's just pretty much, OK, so this is a little bit more complicated because we have the multiple renderers or multiple plots overlaid. But you're basically defining some labels, you're defining some axes, you're defining some scales, you're taking these plots, and then you can put them together in a table. So the reason we chose a table abstraction for laying components out is it lets you really do a lot of stuff you might want. We could have separated this into like 4 subplots if we were excited about that, and then have each of them have their own axes. We can put in legends and so forth. Similarly, with this final chart, we have a scatter plot, and now here we've set, say that you want some custom logic to execute on deciding how to lay things out. In this case, this scatter plot is showing the commits over time to our repository. It's color-coded by who the committer was, and then it's the vertical scaling is what time of day. So you can immediately see some things like I have kind of erratic sleep cycles. And then I used to be a really prolific contributor to the repository, and then I got interns, and it kind of switched to them contributing and me like putting in a bug fix when I get the chance. And once again, the code is relatively short for the main part, where we have this scatter projector. But now we have something like an hour accessor. So we wanted to put it on time of day. That wasn't a property of the data. So I wrote a function which will figure out what hour of the day it was. And then you can just plug it in here, and it will automatically run it on the data and then put it through the scale to put it onto the plot. And I could have changed also, like I have the radius and opacity set here. And I could change that with code, or I could make it a property of the data. So I could, if I wanted, make it a lot more opaque and smaller circles. And you'll see how it looks different. So the reason bayd3 for this library is that Palantir, my employer, wants to shift our entire data visualization stack out of Java Swing and into the web. So we wanted to make a library that's robust and highly performant, but also really flexible, since Palantir, the software needs to be able to generate arbitrary dashboards as opposed to one specific visualization. So what we've tried to do here is make the components be really small, really modular. So if you wanted a different legend, or you had a special type of plot, or instead of a data axis like this, maybe you wanted to display dates on a logarithmic scale for some reason, you could write that little piece and then push it to our repository, and it would just kind of play nicely with all of the other stuff. And the result is that from making a visualization like this with the, it also does window resizing, with the legend and the custom scales and so forth would take, I think, at least several hours with pure day3. But with this library, you can just get all these pieces that already work, maybe put in your one little special visualization piece you want, and be done in an hour or two.
Cool. All right, hello, my name is Paul. So I run a company called Blockspring. And what we're doing there is we just realized one day that the D3 community, we're making some really crazy stuff. And if you just every time I look at Mike Bostic's blocks page, my mind just explodes. But it turns out that a majority of people, like the world is only 0.02% software developers, and then there's a billion people that have Microsoft Office and Excel on their computers. So there's a lot of people that are looking at this stuff and are like, how can I get this? But it's really hard to actually distribute the visualizations that you're creating. So people end up using things like Tableau, which are all all the visualizations are built by a handful of engineers who are trying to predict, what are you going to want with your visualization. So we designed this thing where the whole point of Blockspring was to be able to take the blocks that you create and without really changing your code, to be able to make them really accessible for people that just have data. And so what we do is, I won't go into the actual details, but we let you create this configs.json file that says, here are the variables that I want people to be able to change, and here's where I want people to plug data. And then you could just push your blocks straight up to this platform. Like for instance, this is just, it's not like an extension of our website class. This is just straight up HTML, CSS, JavaScript that you could just push on. And what it does is it just builds an automatic form. So you say you want CSV input, so it lets you upload a CSV, and you never have to touch JSON or anything like that. And then you tell it, I need a text variable, a count variable, whatever. And so you let people actually choose that out of their data set. And this is just a random data set to make a word cloud, I guess. And then the next part is you could customize variables that you want people to be able to change without actually changing your code. So here I said I wanted the number of words to be a variable, the angle of the word clouds to be a variable. And then finally, you could just basically make and publish graphs. The other part that we wanted to build in is to actually get the graphs to communicate with each other. So that's something where we have this dashboards page where without one block knowing that the other block exists, you could actually start building dashboards off of the same data set, and they actually can communicate with each other. Let's see if I actually have one. So this one, let's see if this works. This is a slick grid table with a JQplot scatter plot, an NVD3 scatter plot, a sparkline. You have horizons, you have digraph, you've got D3 cloud, you've got all this other stuff, and none of them actually know about each other. But they're all in this one dashboard that anyone that knows nothing about JavaScript can create. And if you could actually tie them together and actually have them talk to each other. And so that's what we built. And now basically what we're doing is we have customers that are trying to get more blocks onto this platform. And so if there are any D3 visualization experts, we'd love to work with you. We're actually contracting one to three of them over the next month to literally just build blocks that will get used by companies. So this is Blockspring, and we just kind of take your blocks and are able to distribute it to people that need them. Thanks.
Hey everyone, name is Miles McCrocklin. I help organize bayd3 every once in a while. So a couple months ago I posted a thing called Fitzbar, and I just really wanted to chat about it and see if there's any interest in talking about interaction design approaches for data visualization. Fitt's law is kind of like the interaction designer's kerning. If you're familiar with typography, it's that one thing that you'll just, once you learn about it, it'll annoy the heck out of you every time you interact with any kind of user interface. And it's very simple. One of the things, what it basically means is whenever you have a pointer and you're trying to move your mouse or move your finger around an area, the thing that you're trying to reach, the error for that is directly proportional to the distance that you have to go and also the size of the object. So here's another small example of what that basically means. But with data visualization, when you're building interactive data viz, you end up having these issues where the thing that you're trying to interact with is proportionally scaled to the data that you're building your chart on top of. So there are a couple of ways to mitigate this, and in this example, I have Fitzbar, which this takes an approach where you actually just completely omit the X or the Y dimension for the user for interaction with that component. So when the user is scrolling over, they're not bound by the size of the bar. They can, however, still be bound by the X width of the bar. But this is not the only approach to mitigate Fitt's law. You can also take a thresholding approach, which is once you get below some certain unit of measurement that you're not okay with letting the user interact with, you basically give that space the available interaction. So yeah, is anyone interested in maybe more talks around this kind of stuff? Okay. Yeah, and the other thing I just wanted to mention, because I heard people talking about NVD3, about a year and a half ago, recommended NVD3 to people, but this project is it is inactive, if not dead. So I would recommend taking a look at some of the other charting libraries out there as well, because you might not have a lot of support if you try using this. So.
All right. How many of you guys use Bauer? Couple people? So quick introduction, Bauer is a package manager mainly aimed at front-end developers. So I'm on the Bauer team, and what I do mostly is instrumentation of tracking. So we try to keep track of how many packages are installed and how many people are using Bauer. And then I also built this dashboard where you can show how many active users there are on Bauer. And then you can also see where Bauer is around the world that is popular. So you can show by density as well as absolute number of users. So you can see that US is pretty dominant, and also Great Britain, France, Germany. And then you can also see the things that people do on Bauer. People install packages, uninstall, register, and they also search for packages. You can also see what's really popular. So you can see that jQuery is by far the most popular package that is used by front-end devs. And I would say that this is a pretty representative sample. I would say about 30% of the Bauer users send stat voluntarily, so we can keep track of what's popular and what's not. And you can also look at the long tail and look at what's being popular lately. So you can see a lot of things are related to Angular. You can see who the most popular contributors are. Basically, I'm showing you guys this because we have a ton more data that we can analyze. So for example, we can actually go into these packages and look at longer term trends, look at what versions are installed, look at the dependencies, see which package is the most dependent upon. A lot of stuff that you can do with NPM, we can also do with these front-end packages. So we can definitely use more contributors to help with data visualization and also just the project as a whole. So that's it. Yeah, so a lot of this actually has a lot to do with Google I/O. So after Google I/O happened, the Polymer packages, you can actually see some of them up high here, like this one right here. They actually went up a lot of spaces, which pushed a lot of the other packages down. But now that it's been 2-3 weeks after Google I/O, so now the Polymer packages are dropping, and the other packages are coming back up. So it's pretty interesting. Sure. Yeah. Yeah. So this is not that useful because it's basically sorting by ranking, right? So you can see like the top packages are always jQuery, Angular, and Bootstrap. But what will be interesting is to actually see the velocity of change. You can actually surface what's being most talked about. So you don't have to go to Hacker News every morning to look at the most popular front-end package. You can actually just see here because I will argue that the very majority of front-end packages are already on Bauer. So, and yes, it is built in D3. Yes, so the data is publicly available, although it's not in a very easily accessible format. So what we're doing is building a per package API. So it's just a REST API. You can curl it. You can actually build your own dashboard on top of it. We want to do some really simple stuff for the community, like you can have badges that show your install stats if you are a publisher of a package. So again, a lot of stuff that NPM already does, but we're trying to do it in a more interesting way, if you will. Thanks.
All right, and I guess lastly, I'm going to demo real quick something I've been working on. Where I work, we're building this new, we're building our app on this new MVC framework called Derby.js. It's kind of akin to Meteor in that it's sort of front end and back end, and it's got like a reactive model thing and templates and real time. So I made this example of 3 bar charts implemented with pure JavaScript and Derby, some D3 for doing scales and laying out, and then like sort of full D3 to handle changes. So if anyone wants to go to this URL, you should be able to play with me, changing the data, adding and removing bars. I just want to, is anyone online? No? So I can show it in 2 browser windows, so you believe me, but it's more fun if other people play. So you can see that, like, I guess now someone else is drawing along. One of the things with this is that like these update immediately because it's just listening to the changes and the attributes and just rescaling the height. And this one is more the reactive thing where it's like listening on any changes to the data and calling the update, the bar chart update thing, and therefore the transitions are able to happen. But with real time, you start getting these interesting things where like, do you really want it to transition if things are changing really fast, right? And or do you want it to move smoothly? So yeah, this is all pretty new stuff. We're playing with it, trying to figure out how data viz and real time works best together. So it's all open source too. So yeah, I just wanted to share that real quick. All right. Well, thank you everyone for coming out. Hopefully you get to catch some of the speakers and the show and tell people to ask them about what their even deeper thoughts about things. And we'll see you guys next time. Thank you.